Okay, here's part 2, graphing the logarithmic functions. Okay, so what we're going to have you do is graph both the exponential, which we know how to graph because we just did those yesterday, as well as its inverse on the same graph. Okay, so let's start y equals 2 to the x. So we know what that graph is going to look like. It'll go through 0, 1 and through 1, 2. Has a horizontal asymptote at 0 and shoots up like this. Right, so for that one we know its domain, we know its range, we know its x-intercept is none, its y-intercept is 1, and its asymptote has a horizontal asymptote at y equals 0. Okay, now what it wants us to graph is y equals log base 2 of x. Okay, log base 2 of x is the exact inverse, right, which means that it is going to be exactly reflected over the line y equals x. Okay. And all of my x's and my y's are going to be flipped. So instead of the point 0, 1, I'm going to now have the point 1, 0. Instead of the point 1, 2, I'm now going to have the point 2, 1. Instead of having a horizontal asymptote, like I did for the exponential, I am now going to have a vertical asymptote at x equals 0. My graph is going to go in a similar fashion, so it's going to come up like this, and then it's going to grow really, really fast in that direction. So this is my basic log graph. This is log base 2 of x, and this was y equals 2 to the x. Okay, so let's answer questions about our domain. Well, my domain obviously just starts at 0, so it's just 0 to infinity. My range is going to be, in this case, negative infinity all the way up to infinity, so that's all reals. Notice what happened here is that my domain became my range, and my range became my domain, because I'm taking the inverse. So my x's and my y's are now switched. Same exact thing's going to happen here. Notice I no longer have a y-intercept, however I do have an x-intercept, and it is at 1, 0. Okay? How about that asymptote? Instead of a horizontal asymptote now, just like we mentioned, we now have a vertical asymptote at x equals 0. Okay, so everything has flipped. The next one with the 3 to the x is going to be exactly the same idea, right? So let's briefly graph those. So there's my graph of y equals 3 to the x, and then my graph for the log, right, will just look like this. Again, notice how it is a reflection over the line, y equals x, and they are complete inverses of each other, right? Again, you're going to notice the same exact thing happening here. My domain is now switching, and it's going to become the range. My range is now going to become the domain. The x-intercept is now the y-intercept, and the y-intercept is now the x-intercept. That horizontal asymptote that we had before is now going to become a vertical asymptote at x equals 0. Let me just fill these in. Okay, so that should make sense. Now what we're going to do is we're going to take those log graphs, so those two green graphs, y equals log base 2 of x, y equals log base 3 of x, and we are going to transform them on the next page. So let's start this first one. There are 6 examples here. And what I'm going to do is I'm going to do a few of them and then let you work, and you'll check your other answers. I'll kind of go quickly as we go through all these here. Okay. Okay, so that first one, how does that get transformed? We have log base 3 of x, plus 1. Okay, so again, all that plus 1 is going to do is it's going to go up 1. Okay, so the entire graph is going to go up 1. Well, let's go ahead and graph the original parent function of log base 3 of x. So again, it's going to have an x-intercept now of 1. It's going to have this vertical asymptote here, and then it would go through the point 3, 1. Okay, this would be my parent function. I want to take that parent function and I want to shift everything up 1. So this point 1, 0 will move up 1. The point 3, 1 will move up 1. My vertical asymptote doesn't change, and so that's going to stay the same. It's just that my graph is going to move up in that fashion. Okay, the x-intercept is no longer decipherable here. I'm not really sure where it is. It's somewhere between 0 and 1. So I am going to actually have to use some algebra here to plug this in. So to find an x-intercept, as always, I'm going to plug in 0 for y. Okay, and I'll have 0 equals log base 3 of x plus 1. Well, let's start solving this. I'll move the 1 over. So I have negative 1 equals log base 3 of x. And now what I want to do to solve this is I want to rewrite this in exponential form. And so my base is 3. So I'll come over here. Base 3 raised to the negative 1 exponent is equal to x. Well, let's rewrite that as 1/3, and that is my x-intercept. And so it makes sense that it would be somewhere between 0 and 1 according to my graph here. Y-intercept, since we still have the vertical asymptote there, and we know we can never cross a vertical asymptote, there will be no y-intercept. The asymptote is still a vertical asymptote at x equals 0. Okay, for the next one, how is this one going to shift? Since it's a plus 1 in here, we're going to go left 1 inside the parentheses. So again, my parent function, this is a base 2 this time, so the point is 2, 1. There's my parent guy, and it's going to move left 1. So the point at 1, 0 is now at 0, 0. The point at 2, 1 is now at 1, 1. What else has shifted left is that vertical asymptote. So my VA has now also shifted left to x equals negative 1. And so my graph will come up like this and then grow in that direction. Okay? X-intercept, pretty obvious. Y-intercept is the same. That asymptote now has shifted to x equals negative 1. Okay, with the negative out front, what's happening here? Right, so the negative out front is going to flip over the y-axis. I'm sorry, the x-axis. My bad. Changing the sign of my y values and flipping over the x-axis. And so again, let's do the parent function. We're 4, base 4, so 1, 2, 3, 4, 1, and 0, or in 1, 0. So there's parent, sort of a flatter graph with the base 4 there. But I want to flip that over the x-axis, so here's my x-axis. When I flip over the x, this guy stays the same, but this one shifts to 4, negative 1, and my graph is just going to look like this. Okay? Vertical asymptote has not moved. X-intercept, no y-intercept still. Asymptote is still at 0. Okay? 3 more to go, and these 3 are a little bit more involved, as you can see. And then on the next page, we have some natural log ones. Okay? So what I'm going to do here is I am going to let you guys work on this because I don't want to waste the whole video going over these. Just make sure with this one, let me give you a couple hints here, right? This would be, switch this around, negative x plus 2. But then remember you have to factor out the negative, so that's actually going to become negative parentheses x minus 2. So the 2 moves are you'll do, the first thing you'll do is flip over your y-axis. And then the second thing you'll do is you'll shift 2 to the right. Okay, because it's a minus 2. For this one here, since the negative's out front, you're going to flip over your x-axis. The plus 3 off to the side, notice there's no parentheses here. There's a big difference between letter B, which had the parentheses, and letter E, which doesn't. So this is just going up 3. Okay, so flip it and then up 3. For this last one, remember to factor out that negative and then do the minus 1. So what do I have here? I've got to flip over y. I've got left 3, and I've got down 1. So I'll let you guys go back and work on all of these, okay? Work on these 3, and then we'll put up the answer key on the website so you can check all 3 of those, okay? On the next page, these are natural log graphs. Now, natural log graph is going to be exactly the same. This is just a log base e of x, okay? So it's going to be the same thing, and that base e is just 2.7. So it's between the 2 and the 3. So let's think about what this would look like. Well, it's still going to have that x-intercept at 1, 0. And then instead of being at 2, 1 or 3, 1, it's going to be at 2.7, 1. Right? That's where that other point will be. I'll still have a vertical asymptote at x equals 0. I still won't have any y-intercepts. Okay, and it's still going to curve up in that same direction. So then you can do the same sort of transformation. So this would just take this graph here on the left and move it up 2. This one, again, I rewrite, then factor out the negative. So I would flip over y-axis and then go right 4. Okay, so those 2 steps. So flip it and then move it. And then you'll want to solve your answers here for everything else. Okay, I want to get to examples 4 and 6. Sorry, that should be a 5. To talk about domain, and then I'll be done. Again, you can do these on your own. Come back and check the answer key. Example 4, find the domain of each function. Okay, the important thing to remember is that the argument of a log function is always positive. Always, always, always. Okay, memorize it. Okay, so what do I mean by that? I mean the argument, that's this part right here, that whole thing. So for this one, it's just this one because there's no parentheses. For this one, it's the whole thing. So if there's parentheses, it's everything in the parenthesis. When there's no parenthesis, it's just the thing that's right after the log. And this works for logs or for natural logs. Okay, the way I want to set it up is it's always positive. So I'll do 12 minus 4x greater than 0. X greater than 0. X squared minus 4 greater than 0. When I go to solve this, I just solve it like I would solve a regular inequality, right? So I would subtract my 12, divide by negative 4, which flips my sign. And so my answer would be negative infinity to 3, always writing in interval notation. This would obviously just be from 0 to infinity. This one, ooh, what do I have to do? Are you all saying it to yourselves? Key numbers. Okay, so when you go through the process and do key numbers, which you all know how to do, -2, +2, right? Looking at your intervals, you're going to get positive, positive, negative. And so my 2 positive ones would be negative infinity to -2, and then 2 to infinity. Okay, whoops, sorry, that kind of got cut off. All right, so don't forget that you could have key numbers in here when you're finding a domain. All right, the last 2 examples here. Solve this equation, give the exact answer and approximate answer. All right, so to solve log equations, now this should be review, but let's walk through the steps. There's a couple different ways to solve them. If they have bases that can be rewritten in the same base, you would do that. But 10 and 16, yeah, can't really do that. So what I would do is I would rewrite this in log form. Okay, so what would that be? It'd be log base 10 of 16 equals x over 2, right? Well, what's log base 10 of 16? Well, I'm not sure, which is why I'm going to have 2 different answers, an exact answer and an approximate answer. So for this one, trying to solve for x, I would just multiply both sides by 2. And so my exact answer would be 2 times the log of 16. Notice since it's base 10, common log base, I don't need to write the base. And that is my exact answer. My approximate answer would just be to use calculator. Okay, and so I would just type that in, the log of 16 into my calculator, and I would get, I don't know, some decimal, 1.204 something, something, something. And so x would just equal 2. It didn't say what it wanted you to round to, 408, etc. Okay, and so this is my approximate answer. Okay, for this last one, it's a natural log equation, but it's the same thing. So I'm just going to rewrite it as a natural log of 5,000 equals 2t minus 5. Again, for exact answer, I'm going to keep it like this, not use my calculator. Add the 5. So then I just have natural log of 5,000 plus 5. Divide everything by 2. And so it would be natural log of 5,000 plus 5, all divided by 2. This would be my exact answer. For approximate, again, I'm just going to take this, type it into my calculator, and so calculator gives you some approximation, something like that, and you approximately get 6.7586. And again, this would be my approximate answer. And that's it. Go back and finish those other graphs and then check the answer key online.